Hello everyone, this is Shoham and welcome to my channel Physics with Shoham. So after a long time I am back in YouTube. So today I am not going to teach anything, but instead I will perform an experiment on diffraction of light. Yes, you heard me right, that's diffraction of light. So you are going to enjoy the experiment very much, and I will be using very simple apparatus to make the experiment, which are found in our homes. Okay, very simple, no costly things or anything. Okay, so now I am going to start the experiment, but before that I will just discuss the thing diffraction of light and how I am going to perform the experiment. So let's start. So what is diffraction? So diffraction is a property of waves, right? So we know that light has wave particle duality. So light has a wave nature with it. So light bends around, or any wave bends around sharp edges or corners. The size of the edge should be close to the wavelength of the light used or the wave used, right? So that is called diffraction. The experiment which I am going to perform today, there I will be showing you the bending of light when it passes through a slit, one single slit. That is called single slit diffraction. Now you will ask me that how will I understand that light has bent while passing through the single slit? Due to this property of bending, light will enter its shadow region. That means the geometrical shadow that should have formed, the light should not have reached there, but due to the process of diffraction, light will be able to reach the shadow region, right? So that is how we can understand that diffraction is taking place. So for doing this experiment, the slit should be very small. It should be in the order of the wavelength of the light, right? If the slit is large, then we won't note any difference. So the slit should be very small, and the distance between the slit and the source should be comparably large, right? So now let us see the experimental setup. So this is my experimental setup for the experiment. So the setup consists of three main items, that is the source, the slit and the screen. So for the source I have used a red laser pointer. This is a red laser pointer. This is very cheap. It costs only 40 rupees. This is available in the market. This is very common. And this clip I am using just to clip this, just to push this button on, so that the light always comes out, because this has to be always pressed to keep the laser on. Okay, if you release it, then it will be off, like that. So I will be using this clip to press the switch on. Now let us come to the slit. This is the slit. For making the slit I have used the shaving things, that is the blades used for shaving, and these black clips which you can see I have also used in case of the slit. These clips are I have taken from my balcony, which are used to hang clothes. Okay, so this is all, every component is available, very common in our house, right? So this is the slit and this is the source, you can understand. And let us come to the screen. The screen is nothing so special, it is just my whiteboard which I used to teach, right? So I used to write on this whiteboard, so that will be the screen for today's experiment. So this is the full experimental setup in one frame: the source, the slit and the screen. Now what I will be doing is that I will be turning on this light, this pointer, laser pointer, and I will be shining it directly right at the slit, right at that small opening. Okay, and if I am not wrong, I should see something very beautiful on the screen, right? So I have turned off the lights so that we can get a very good view. So as I told you, the laser is on and the light from the laser is directly hitting the slit. See, exactly at the slit the light is hitting, right? So now I am going to shift my camera to the screen, and this is the beauty. See, just take some time and try to understand what's going on here. Isn't this beautiful? You can literally see the dark spots and the bright spots. In the center we have the so-called central maxima, and on either sides of the central maxima we have the fringes, the dark fringes and the bright fringes. It is exactly what happens in Fraunhofer's diffraction. The central maxima is of the maximum brightness and maximum width, and the rest are small, and their intensities are decreasing as we go further away from the central maxima. Just look at it. How beautiful it is. Now what I am going to do is that I will be further decreasing the slit size, and then I will be showing you the new pattern that would be different from this one. So now I have made a small change, that is, I have decreased the slit size even further. Okay, everything else is same. The light is still hitting exactly at the center of the slit, but the slit size has decreased. And surprisingly, or not the surprisingly, but this should have happened. The width of the central maxima has increased, and not only the central maxima, all the widths have increased in size. See, it is more clear to see now. It is visually more pleasing now. Look at this. Mathematically also we can derive that if the slit size decreases, the width of the fringes will increase. We are getting this interference pattern because the slit is the source of secondary wavelets, or that is what we call in terms of Huygens principle, right? So those secondary wavelets interfere with each other to form the interference pattern on the screen. If you have enjoyed the experiment on single slit diffraction which I performed, then please like this video and don't forget to share it with your friends, right? And subscribe to my channel. We'll see you next time.